this symbol that I have up here on the board looks like a C that got kind of like flattened out a little bit. Usually we have a C that kind of looks like, you know what? My board is not cooperating. There we go. So usually a C looks like that, but if you kind of just like take the ends and kind of flatten them out a little bit, now you got your subset symbol. Okay. That means is a subset of, and it's a very strong thing to say that something's a subset of something else. It means that the thing on the left-hand side is completely within the second group. All right? So A is a subset of B. That means that every single piece of A is in B. Okay, now remember the element symbol? 1 is an element of A, right? Because 1 is in A. When we say A is a subset of B, that means that A, the entire set of A, is inside of B. Okay, that's what it means to be a subset. Not that one piece of A is in B, but every single piece of A is in B. All right? So the one on the left is always the smaller one. The one on the right is always the bigger one. So when we're using the subset symbol, we should expect it to look like that. All right? So, looking at the set of real numbers, let's focus on this part of it first. The first breakdown of real numbers is numbers can be broken down into two specific groups. The first group is the set of real numbers, or sorry, rational numbers. The second group is the set of irrational numbers. Okay? These two sets, the rational and the irrational, are called disjoint sets. What that means is they have no common features. If something gets into the rational number set, it is not irrational. If something gets into the irrational set, it is not rational. It's either one or the other. It can't be both. No fence straddling on this. Okay? You get real numbers, a whole bunch of numbers. They get separated into those two specific categories. Now, if it's irrational, that's all it is. There's nothing else about it. There's no special subcategories of irrational numbers. There's just irrational numbers. These are numbers that cannot be written as a fraction of integers. Okay? That's the official definition. Okay? For your purposes, numbers that have pi attached to them are irrational. Non-repeating, non-terminating decimals are irrational. So if it's a repeating decimal that goes on forever, it's rational. If it's not repeating and goes on forever, it's irrational. So for example, 1.979939112396014 ... That's irrational. ... means it goes on forever. We can see there's absolutely no repetition going on there. That's irrational. If I have 1.93939393 ... that's rational.
It just keeps repeating.
It keeps repeating. It goes on forever, but it repeats itself, which means it can be written as a fraction of integers. Okay? And to prove it, 1.939393939, right? 192 over 99, two integers. Integer over integer is rational. So again, just because you see ... doesn't mean it's irrational. It has to have a non-repetition of digits. Like that. Alright? So, the other thing that you can see, if something irrational, it should have a square root that does not simplify. What's the square root of 4? 2. That's rational, right? Because it simplifies. What's the square root of 5? I don't know either. So that's irrational. Okay, so if it's one that doesn't evaluate, it's irrational. If it's one that does evaluate to a nice whole number, it's going to be rational. Right? So, your first separation of things is either rational or irrational. Once you make that determination, if it just happens to be rational, there's more categories. Rational numbers are all the fractions, terminating decimals, that's decimals that end, and non-terminating repeating decimals, that's ones that don't end but they repeat. If you throw out the fractions and terminating decimals and repeating decimals, you're left with integers. That's every non-fraction that's negative, 0, or positive. Then you have the whole numbers. That's every non-fraction that's only 0 or positive. And natural, that's only the positive ones. Okay, so each time there's a little bit more restriction as far as what something is. So looking at the sets here, on this side, this is the smallest set. It has the fewest numbers in it. This has one more number, so it's bigger. This has a bunch more numbers, so it's bigger. This has all these numbers plus all the fractions decimals, so it's bigger. And this has all the rational and irrational, so it's bigger. So smallest, bigger, 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 bigger. Right? And looking at this set, this is part of those numbers, right? So this is smaller than that, right? So smaller, bigger. So looking at this, and you have to identify something as a subset of a real number, right? Or of this, and what sets they belong to. They're either rational or irrational, Q or I, right? If they're I, that's your answer. If they're irrational, it's irrational and real. If it's Q, then you have to ask yourself, it's one of these also. Then you got to work your way down. So what I do when it says this question here, we'll start example 3. I should put this slide somewhere else. We'll start example 3 here. If it asks me if a number's a subset of real numbers, the first thing I ask myself is whether it's rational or irrational. So look at this one. Which is it?
Red sign.
Is it rational or irrational?
It's rational.
Rational, it's not. So again, if I don't see pi, if I don't see a square root, and if I don't see some non-terminating, non-repeating decimal, then it's going to be rational. So once I see it's not irrational, I'm going to immediately write N, W, Z, Q, R on my paper. That's not the right answer, but the right answer is within that list, in that specific order. Okay, so going back to this page back here, move that a little better here. You can have this page in your possession for right now, but that's something you want to get familiar with. That exact order, N, W, Z, Q, R is the order you want. Smallest to biggest order. All right? Then you simply have to ask yourself the criteria for each of those sets. To be an N, we're looking at a positive non-fraction. For that matter, all three of these are non-fractions, right? Non-fraction, non-fraction, non-fraction. Positive, 0 and positive, negative 0 positive. Every one of these non-fractions. Once I see it's a fraction, I throw those out. There's my answer. All right. 3, 4, and 5 are exactly the same type of question. I'm going to do them all in the same video here. So moving on to example 4. 5. Okay, again, we have to ask ourselves the question, rational or irrational? So what do we think?
Rational.
It's rational. So again, it's not pi, it's not a radical, square root, and it's not some terminating, it's not even a decimal at all, right? So I immediately write NWZQR. Alright? Starting at N. To be N, it has to be a non-fractional number that's positive. Is it?
Yeah.
Yes. Once you hit yes, the answer is what you're looking at. If you get a no, drag it out. If you get a yes, you're done. Circle.
So you have to start with N?
Always start with N, always start with the smallest. Once it belongs to something, it belongs to everything else. Once it's a positive non-fraction, then it's going to be a positive or 0, right?
Yeah.
It's going to be positive, negative, or 0, right? 5 over 1 is a fraction, and 5 is a real number. So once it belongs to one, it belongs to all.
And what if we started with like R or W?
Always start at the small, work your way up. Don't ever start with anything but the smallest. All right? Example 5. 3 square root of 2. Is it rational or irrational?
Irrational.
As soon as you say it's irrational, IR is your answer and you're done. Square root of 2. Square root of 2 doesn't evaluate to some pretty number like 2 or 3 or 4 or 5. So it's going to be irrational and therefore also real.